What were we discussing? 5.5, right? Any doubt from 5.5 concepts or any problems? What we do? Guys, those are online, are you able to hear me?
Yes, sir.
Okay. All in.
So,
All in.
now it is test or class, sir? Sir,
Yes, ma'am. Yeah, tell
Sir.
me.
now it is test or class, sir?
Now it is class, then you will have test from 6. Okay.
Okay, sir.
Let's go through the concept based from 5.5. There are any doubts, ask me. Or else let's go on to 5.6. You say okay, I'll go to 5.6. And I'll end the session somewhere around 5:15. You'll have 10 minutes time for you to realize with it, then you can write the test. Sorry. What is the time now? 5:5. We'll get started. Yeah. So 5.5 can assume there are no doubts. You guys can do it, right? And solutions are also already uploaded in the app. I think I've solved 8 problems or something, and the solutions are there. You can go through them. Okay, in spite of it, you have any doubt, you can reach out to me. Is it from 5.5?
Yes. Example.
Then,
Y to the power x
okay.
plus x to the power y.
Okay.
Then x to the power x
Plus x to the power x. Okay.
equal to b to the power y. A to the power
Equal to
a to the power b.
a to the power dl. B.
Sir,
Okay. Yes.
Y
sir, your board is horizontal way, sir.
Is it very small?
No, sir, it is horizontal.
Oh. See, hopefully the projector issue should get solved for next class. Let's see. Is it better now?
Yes, sir.
Yeah, now you're able to see, right? Shubham, are you able to see?
Yes, sir.
Okay, good. So this is the question, and you want
dy by dx.
dy by dx from this, right? So what we can do, we'll take the u is equal to y power x. Okay. Then what we can do is take log on both the sides. Log u is equal to x log y. Accepted? Which implies 1 by u into du by dx is equal to x into derivative of y log y is 1 by y into dy by dx plus log y into 1. Accepted? Now collect dy by dx terms from here. Right. So du by dx, leave it as it is. So du by dx is equal to this u will go to the other side, right? U is nothing but y power x. So y power x into x by y into dy by dx plus log y, accepted. Okay, now you can take dy by, okay, one thing what you can do is leave it as it is, du by dx, leave it as it is. So this is first thing. Now what I'm doing is I'm taking this as u, this as v, and this as z. Okay, is equal to some constant, right? If I differentiate on both the sides, what do I get? I get du by dx plus dv by dx plus dz by dx is equal to derivative of a constant will be 0. So what has happened is I found du by dx. In du by dx, I have dy by dx. So I'll take this and substitute it here later. Okay. Similarly, b is equal to what will I do? X power y. Okay. Then you will get log b is equal to y log x. This can you differentiate it again? Okay, I'll just give you a hint. Later you try. I'm not doing it completely. So how will you differentiate this? 1 by v. So 1 by v into dv by dx is equal to y by x plus log x into dy by dx. Let me call this as 2. This is actually not 2. We should go to the other side. Then you call that as 2. Okay. Similarly, what you have z is equal to x power x. Right? X power x, you try to differentiate, right? You will get dz by dx is equal to, you can try and see it. You will get this as x power x into 1 plus log x. So there's already a previous formula. Right? You will get this thing, x power x into 1 plus log x. Is that clear? Sanjeevan, you can go to the. So x power x into this thing, this is the third one, add everything and equate it to 0. From there, collect dy by dx terms. That will give you the answer. Is that clear? How can you do, right? So this problem is slightly lengthy. At the same time, practice it again. Right? Shall I proceed, guys? Yeah. Any of this? So the next exercise, 5.6, is about derivatives of parametric functions. Okay, what are they? Derivatives of parametric functions. So if I take x in terms x as a function of some variable theta, and if I take y also as a function of the same variable theta, then you say that these two are parametric equations for a given curve in terms of x and y. Let me give you an example for it. You have a circle, and for the circle, right? See the marker. So if you consider a circle, let's say with the center as origin. Okay. So if you take the circle with the center as origin, and if I take a point x comma y, okay, and let's say the radius of the circle is a. Tell me the equation of the circle. X square plus y square is equal to a square. Correct? Let's say this area is not area. The radius is making an angle theta with respect to the x-axis in anti-clockwise direction. Then if I drop a perpendicular from here, how much can I call this distance as? Can I call it as x? And can I call this height as y? So what is x divided by a from the triangle? Cos theta. And y divided by a is sin theta, which implies x is equal to a cos theta, which implies y is equal to a sin theta. Means x comma y is a point on this curve. The same x comma y, what you get is, instead of writing it as x and y separately, you try to write it in terms of radius and angle. So x is a function of theta, y is also a function of theta. Then this is called as the parametric equation of a circle with the center as origin. Are you able to understand what I'm trying to say? In a similar way, I'll just give you some more examples. If suppose I give you a question like this, x is equal to a cos theta, y is equal to b sin theta. You have to understand the difference here. A cos theta, a sin theta. Whereas here, I'm changing the parametric equation. X is equal to a cos theta, y is equal to b sin theta. Where a and b are different. Now, this a sin theta and b cos theta are also called as parametric equations. But for which curve? Why I called it as parametric is, listen, if I square and add, then what will I get? X square plus y square is equal to a square into cos square theta plus sin square theta. What do I get? Is that not the equation of circle? X square plus y square is equal to a square. Means a cos theta and a sin theta is satisfying this equation. In a similar way, a cos theta and b sin theta would satisfy this equation. Let me see how many of you are able to guess. Check. You substitute it here, a square cos square theta, a square are 1, cos square theta plus b square sin square theta, b square are 1. So sin cos square theta plus sin square theta will be 1. So x is equal to a cos theta, y is equal to b sin theta is also called as a parametric equation. It is called for an ellipse. Okay. So if you see the whole exercise, right, they would have given you these equations, but they would have not told you what those equations are actually. Generally, we use them only for competitive exams. Okay. Are you able to understand what I'm trying to say? You are able to get a feel of what is parametric equation, right? So in a similar way, if I have x is equal to a secant theta, y is equal to b tan theta, then this would be the parametric equation for. So what is the relation between secant and tan? Secant square minus tan square is equal to 1. So this will be the equation for x square by a square minus y square by b square is equal to 1. Are you able to understand? Now I will relate what will be the answer when you directly differentiate the function or when you differentiate the parametric function. Is the answer going to be the same or are they going to be different? This is what we are going to test. Is it clear? Yes. Can I rub this? Right. Now, first, let me take the same example of equation of circle with the center as origin. Okay. So when I say derivatives of parametric function, I say x is equal to a cos theta, y is equal to a sin theta. Suppose I give you an equation like this, then I am putting a question: find out what is dy by dx and tell me. Okay. So for me to get dy by dx, can I write this as dy by d theta divided by dx divided by dt? Means I will differentiate y with respect to its independent variable, differentiate x with respect to its independent variable, and divide it. So what is dy by d theta? It is a cos theta divided by
Yes, sir.
that minus a sin. So a and a are gone, you get minus what this is answer. So to put it in simple terms, whenever you see x and y both in terms of same independent variable, it can be theta, it can be t, it can be z, whatever it is. Other than x and y, you will find something else, but it will be common for both. It will be common for both x and y. Here it is theta. So differentiate y with respect to the independent variable, differentiate x with respect to the independent variable, divide both. That is the answer. Is it clear? Now listen to this carefully. Pay attention. Can I say a cos theta, comma a sin theta is a point on this curve? Because x comma y is a point on this curve. So can I say this point is a cos theta, a sin theta? Can I write except this? Now listen. I have x square plus y square is equal to a square. What kind of function is this? For time being, can I call it as an implicit function? The third if it's a second or whatever it is, right? What will it generally do? Differentiate out both the sides. So you have 2x plus 2y into y dash, that is dy by dx, is equal to derivative of a square. It's a constant, radius of the circle. So what is y dash equal to? Is it not equal to minus x by 1? Rearrange it. Are you guys getting the grip over it? So minus x divided by y. But what did I tell x and y are in terms of parametric forms? X is a cos theta and y is a sin theta. Forget about this minus. This and this will get cancelled. You are getting stuck. Are they both the same? If they give you an implicit form, you first differentiate, then substitute the point. If they directly give you a parametric form, find dy by the derivative of independent variable, dx by derivative of independent variable, divide by this. This is the whole algorithm. Nothing else. Actually, you need not do this. You will get a grip over this in the next chapter. Actually, what I did is I found the slope of a tangent. Generally, you know why we differentiate? Why do we differentiate? Find the slope of a tangent at a given point. So what I did here is, to the circle, if there was a tangent drawn at this point, what would have been the slope of this tangent at this point? Answer is minus 1. That is the actual meaning of it. Okay, I combined three things: parametric equation, implicit functions, and tangent. I hope there is no confusion, right? You're clear, right? So what I would suggest is, with respect to mastering this exercise, go with the parametric form. Don't think anything outside. I explained this only for the sake of knowledge. For this exercise, go by dy by d theta, dx by d theta, and then so on. You have to do this. Shall we do some problems? Once you copy this. Guys, those who are online, are you clear?
Yes, sir.
Yes, sir.
That's right. Copy it. This part we done. You differentiate the same function in any form, answer will be the same. So I'll just give you, since you asked this question, the objective of 5th chapter is only to give you a practice of different forms of differentiation. Because you take all this knowledge and apply it to the 6th chapter. Rather than the chapter on the applications of derivatives. Okay, so it's rather they are actually splitting it as different concepts. That's it. So to answer your question, value will not be the same. Clear? Derivative of parametric. Derivatives of parametric. Can I rub this base? Yeah, we'll solve some more problems. Right. Tell me what is the next question. We go with X next. Okay. Example, you guys take the place. X is equal to 280 square. See, generally, whenever this P variable is used, right, it is mostly used for parameters. They generally use it for parameters. But all you want to find it, right? Can you tell? Maybe it is out of context, but can you try to tell me these are the parametric equations of which curve? So it's very simple, okay? What should you eliminate in both? To get the equation of curve, what are you supposed to eliminate? You need to eliminate this. So T square is equal to, can you write it as x by 2a? Y is equal to a into T square the whole square. Correct? So a into, in the place of T square, can I write this? X square by 4a square. Or I write it as x by 2a the whole square. So what you get? X square by 4a square into a, which by cancel them, take this to the other side. X square is equal to 4a. This is the actual curve for which any point on the curve is the same. And then
It says y is a t square to the power
P square the whole square.
So
P square itself is x by 2a.
so then t is
So x by 2a. Yeah, why should I find t when I have t square? Here there t square. I took this t square and substituted. Are you able to understand? Right. But this is not our objective. What is our objective? Find dy by dx. How do I do? What is the algorithm I go to? What are the steps to be followed? Find dy with respect to independent variable. What is the independent variable? T. So find dy by dt and divide it with dx by dt. This is very simple. So what is dy by dt? 4 a t cube divided by 4 a t. Correct? 4a are gone. Will be left over. Should not differentiate this because it's a constant. It's a constant. Oh, sorry. Please. Okay. So with the same knowledge, second one, tell me what is the first one? Y is equal to a cos, x is equal to a cos. X is a cos theta. Y is what curve is this? B cos theta or sin theta? B cos theta. What will be the answer? You yourself tell me. B by is. So dx by d theta is minus a sin theta. dy by d theta is minus b sin theta. Divide both. So dy by d theta divided by dx by d theta is going to be 2. It's a simple problem. Correct? Any idea of where this point lies on? What curve does it? Any idea? Any guesses? X is equal to a cos theta, y is equal to b sin theta. What are you supposed to eliminate? Cos, right? Divide both on both the sides, you will get x by y is equal to a by b. So y is equal to b by a into x. This is not looking like the form y is equal to mx. It's actually by secant passing through origin. So you have to have a good grip of this thing also, because in applications of integrals, they'll ask you to problems. So it's better you start adapting this method. Math will become easy. Seriya? So clear? So third one. What about the third one, guys? I'll tell you what all things you can do. Third group you can do, fifth also you can do. Okay, I'll do from fifth onwards. You couldn't do it. What is the problem? X is equal to? Okay. Cos theta. Okay. Cos theta. Let's not worry about finding the term. So what is dy by dt? Minus 2 sin 2t. Dx by dt. Cos t. So what is dy by dx?
Sir, video got off, sir.
Yeah, Shubham, you told something?
Sir, video got off, sir.
Oh, sorry. Is it better now?
Yes, sir.
Yes, sir.
Okay. So dy by dx will be equal to minus 2 sin 2t divided by cos t. Sin 2t, what is the formula? 2 sin t cos t. So it will be minus 4 sin t cos t divided by cos t. Cancel it. Answer will be minus 4 sin t. I'm not sure how the answer is given at the back. Minus 4 sin t. Fourth is easier. X equal to 4t, y is equal to 4 by dr. 4t, y is equal to 4 by d. What is dy by dt? Minus 4 by t square. Derivative of 1 by d is minus 1 by t square. Everybody knows this, right? So dx by dt another 4. Then what is dy by dx? Minus 1 by t square. That's the answer. I'll do slightly tougher problems. Okay. How many more are there? 11. So fifth one is there. So fifth one, what is the question? X is equal to a value. No a. Minus cos 2 theta. Okay. Y is equal to sin theta minus sin. What is dy by d theta? Let's do directly. No? Cos theta minus 2 cos 2 theta. Any doubt in this? Cos theta minus 2 cos 2 theta. Change it. Anybody having doubt? This share a doubt. In the total expression. Here. So dx by dt minus sin theta plus 2 sin 2 theta by plus because cos is derivative is minus sin. So what will happen to dy by dx? Minus sin theta plus 2 sin 2 theta divided by cos theta minus 2 cos 2 theta. Okay. So actually you can leave it like this. How is the answer given? You can simplify it now. Because when you write sin 2 theta, right, I'm able to take cos outside. This one only, no? You can leave it as this. I'll tell you why, but oh, sorry. I'll tell you why I will simplify. Cos theta minus 2 cos 2 theta divided by minus sin theta plus 2 sin. Why I couldn't do it is because when I observed the sin to theta, I got 2 sin theta cos theta in mind. So I thought I can take out sin theta. Right? But in the numerator, what is happening? Cos theta is there, but cos 2 theta, the formula is either 2 cos square theta minus 1 or 1 minus 2 sin square theta or cos square theta minus sin square theta. So I don't have anything common in all the three. So if I start solving this, it will become a tedious process. It's better to leave it like this. So, yeah. Sometimes you might get a doubt of when to simplify, when not to simplify. So whenever things are complicated and not common in the numerator and denominator, leave it as this. Whenever this. Yeah. You guys are copying it. So what are the 6 permits? A into theta minus sin theta. Correct. Y is 1 plus cos theta. Simple, no? So dy by d theta is what? Minus a sin theta divided by dx by d theta is how much? Can I write it as a into 1 minus cos theta? Can I do this? So this will be minus a sin theta divided by a into 1 minus cos theta. So I will write this as 2 sin square theta by 2. 1 minus cos theta is 2 sin square theta by 2. Then how can I write sin theta in terms of sin theta by 2? It is 2 sin theta by 2 cos theta by 2. So now you are able to understand in this problem there is something going to be common in the numerator and denominator. That is why we can simplify. So this and this will get cancelled. 2 is gone, a is gone. So we get minus cot theta by 2. Very nice. So someone keep checking the answer. There's any mistake. Correct. So minus cot theta. Let me proceed to the next one. Seventh, what is this? I think that's slightly tougher. Root is or collected denominator. So seventh one, what is that? Theta. Sin cube sin cube t divided by root cos 2t. Y is equal to root of cos 2t. One advantage in both is denominator is the same. So when you do u by v, right, denominators we can cancel. Okay. So dy by dt in our root of cos 2t into derivative of cos 2t is 3 cos square t into minus sin t. Correct? Minus cos cube t into derivative of root cos 2t is derivative of square root is 1 by root of cos 2t into minus 2 sin 2t. Correct? The whole divided by, I'll put it like this. This whole thing divided by cos 2t. I wanted the space. It's clear. So is there anything that can be simplified? So one thing that we can do is the square root is disturbing here. But I'm able to find another square root here. So what I do is I take LCM. So when I take LCM, what am I going to get? First thing, note that this 2 and 2 will get cancelled. Minus of minus is going to be a Yes. So the square root p, root cos 2p is the LCM. So here it will become cos 2p into 3 cos square p into minus sin p plus sin 2p into cos 2p, the whole thing divided by cos 2p into root cos 2p. Is there any questions? Right? You understood, you should not leave it as cos 2p. That is getting multiplied with this denominator. That is root cos 2p. Clear? So, is there anything that we can simplify further? Um, Maybe we can take the cos square outside, right? We will do that when we write dy by dx. Okay. Now, what about dx by dt? Same logic. Root of cos 2t is running. Root of cos 2t. Derivative of cos cube is, sorry, this is already written. Dx by dt is root of cos 2t into derivative of sin cube is 3 sin square p into cos t, correct? Minus sin cube t into the same thing, 1 by 2 root of cos 2t into minus 2 sin t, the whole divided by cos 2t, correct? So see, 2 and 2 are gone. Again, minus of minus is going to give you a plus. LCM is root cos 2t. So what will be left out with? We'll be having 3 sin square t into cos t into cos 2t, correct? Correct? Plus sin cube t into sin cube t, the whole divided by cos 2t into root of slightly lengthy problem. You need to be very careful with the calculations. Okay, so this we best practice it again. It's not yet over. Finish here. Okay, now. Good, right and pass. I'm going to write dy by dx. Okay. When I write dy by dx here, I'm going to have 3 sin square t cos t into cos 2t plus sin cube t into sin 2t, correct? The whole divided by what I'm going to have this thing 3 cos square t into minus sin t into cos 2t plus cos cube t into sin 2t. Did I make a mistake? I start it again. With the x by dt. do one thing. I can't run the whole thing. I treat it as dx by dy. Last step I'll write the what will be happening? What is common? So go back here. Mic gets switched. So right, cos to be in terms of cos square t minus sin square t. So right is sin. Wait, let's not expand this cos to t. Let's try to do it by writing sin to t as 2 sin t cos t. 3 sin square t cos t into cos 2t plus sin cube t into 2 sin t cos t divided by 3 cos square t into minus sin t into cos 2t plus cos cube t into 2 sin t cos t. Is there anything that we can take to common? So can you take out the sin square t cos t common? The numerator and denominator. Right. So I write it as sin square t cos t into your left out with 3 cos t cos oh, sorry 3 cos 2t, correct? Plus 2 sin square t. Check. Correct? 3 cos 2t plus 2 sin square t divided by what is going to be the denominator. What is common in the denominator? Cos square t is sin t. Can you take cos square t sin t outside? So cos square t sin t into what are you going to have? Minus 3 cos 2t plus 2 cos square t. Is it right place? Correct. Read out. And let me know if there is any doubt. Remember, it is still dh by dt. We need to find data variance. Okay. One cos is gone, one sin is gone. Right? Now it is easy for us to proceed because I'm clear that since I have sin square t here, I can write this cos 2t in terms of 1 minus 2 sin square t. Can I write it? So when I do that, I get sin t into 3 into 1 minus 2 sin square t plus 2 sin square t whole divided by this as? What should I write this as? I have cos square t here.
Cos square t.
I'll write it as cos square t minus 1 plus
2 cos.
2 cos square. Okay, this will be sin t into 3 minus 4 sin square t. Correct? Observe. 3 minus 4 sin square t. Correct? How did I get 3 minus 6 sin square t plus 2 sin square t? It is minus 4 sin square t divided by cos t into, this is how much? Minus 4 cos square t plus 3. Is it clear? Next. Right, but still things are not getting cancelled. So what I'm going to do is, I will write cos square in terms of sin square. How can I do that? 1 minute. Still not working. 1 minute. Did I miss something? Is there any did I miss any sign? Well, to my estimation answer should have been 40. Minus 40 or something. Or 3D. Okay. We got the answer. Please. Take the sign and multiply it inside. Then I get 3 sin t minus 4 sin cube t divided by 3 cos t minus 4 cos cube t. So 3 sin theta minus 4 sin cube theta. Sin 3 theta. So it is sin 3t divided by 3 cos t minus 4 cos cube minus cos 3t. Right, but still this is what? Dx by dy. Then what is dy by dx? This is the reciprocal of this. So minus cos 3t by sin 3t. It is going to be minus cos. So here it is. I suggest you guys practice this problem. This was 4 marks. Okay, let us practice. So other problems I hope you guys can write. If there is a need of you can reach out. And the last exercise that is left out is called a second order derivative. It will take only 5 minutes for me to explain the concept. I'll explain the concept. You can do all the problems. There is nothing that I need. Okay. So let me know once you are done with this. I'll go to that concept. Guys, those who are online, are you clear?
Yes, sir.
This. Last exercise of this chapter is 5.7, which is called as second order derivative. Okay. 5.7 is second order derivative. See, if I take y is equal to sin x, for example, what is y1? Y1 is called the first order derivative. What is y1? Cos x. So what will y2 be? This y2 is what is called as the second order derivative. In a more mature way, we write it like this. We call this as dy by dx. And this will be d by dx of, see, here you are differentiating y with respect to x. The next step, what I am doing? You are differentiating dy by dx with respect to x. So you write this as d by dx of dy by dx. This is written as d square by divided by dx square. So this d square by divided by dx square is what is called as the second order derivative. Okay, this can also be called as y double dash, or this can also be called as f double dash of x. All these things mean the second order derivative. Double derivative. Why do we call it as second order? Because your differentiation with this number will decide which order it is. If the power is 1, call it as first order derivative. This one is second order. If it goes to 3, it will be third order. Okay. So about order and degree, we'll be learning in a chapter called differential equations. The 9th chapter. As of now, this is outline. For example, you take the exercise, right? There's a question like this. Y is equal to, what is the first question? The x square plus 3x plus 2. What is y dash? 2x plus 3. What is y double dash? Find the second order derivative. First find it once, again differentiate it with respect to that. See, though I have explained the concept, you please try that and if you have any doubt, reach out. That's it from my side. Okay. Yeah, because the chapter is also, you don't have roads there and the feedback. It's the leader. So this chapter is over. Again, you can practice all the problems and the same is slightly tough. This if you want to try it. Okay. So if you have 5 more minutes time, actually you can take 10 minutes. Revise 4 minutes. 6/5 you will get the paper. 7/5 you can solve. Guys, those who are online, any doubt?
No, sir.
Those who are online, any doubt?
No, sir.
Clear, right? Okay. So we'll end the session now. You have 10 more minutes to prepare for the test. Okay. 6/5 the papers will be given to you and then you can work on. I think the papers are already uploaded. Okay, but I suggest you start at 6/5 and try to complete it by 7/5.
Yes, sir.
Okay. Okay, that's it, guys. We'll wind up.
Thank you, sir.